welcome back to the session for the solutions which is related to the open system. And previously we have solved the solutions which is related to the closed system. Let's start with a simple problem. I have given the order of the problem which is according to the level or the weightage, okay, in which the first problem which I am going to solve is a simple problem which has been asked in January 2012 for 3 marks question. Okay, let's read out the question first, understand this, and then we'll try to solve it. A helium gas is escaping from a large reservoir through a attached nozzle. The inside temperature is 90 degrees centigrade and outside temperature is 40 degrees centigrade. What is the velocity of the gas at the exit of the nozzle? Okay, so as far as the open system which we have learned, we have gone through the steady flow energy equations which is applied for the different devices, such a way like which we have gone through nozzle, diffuser, turbine, compressor and all. So this is an example which is related to the nozzle one. Okay, so let's try to calculate this. What is this? We are given data which is over here as given data. Let's try to write what is this. Given data, T1 is 90 degrees, which is equal to 363 Kelvin, and T2 is 40 degrees centigrade, which is equal to 313 Kelvin. So here what is we need to find? To find velocity. Okay, so let's try to draw this sketch, then you will understand this. As this is the velocity which is in and which is out. So here inlet temperature is given T1 and outlet temperature is given as T2. So we need to find the velocity. Okay, so how do you calculate the velocity? As we have the relation V2 is equal to 2 into H1 minus H2 under root. This relation which you have found from the steady flow energy equation, neglecting assumptions. What are the assumptions which you have here? Assumptions: kinetic energy changes, which you are going to consider. We are not going to neglect it, sorry, over here. So we are trying to neglect the potential energy changes. And assumption other one is it is steady flow, and other assumption is uniform flow. Okay, and V1 which is neglected, V1, the initial velocity. Okay, and now from this, as we have got the formula to calculate V2 is equal to 2 into H1 minus H2 under root. But from this relation, which is according to this, there is no enthalpies which is given. So how do you calculate the enthalpy? H is equal to Cp delta T. Okay, H by M. So from this, where delta T is nothing but T1 minus T2. So here H1 is equal to CpT1 and H2 is equal to CpT2. So from this, what is we need to calculate? H1. So V2 is equal to under root of 2 into Cp into T1 minus T2 under root. Okay, so here 2 into, whereas Cp, the value which is not given in the problem, but as far as for helium gas it is 5.19 kilojoules per kg Kelvin into what is T1? T1 is 363 minus 313 under root. So from this we get the value as where your Kelvin and this Kelvin will be cancelled. So finally you will get the value of V2. V2 is equal to 22.78 kilojoules per kg. Okay, this is the answer which I got. Okay, I hope this solution is clear. This is a very simple problem which is asked for 3 marker question. Let's try to solve another problem in another session. Problem number 2.